All right, so we're gonna start with our integral properties. There's 3 of them and they're all pretty intuitive, like they make sense, okay? So the first one, integral, and you guys are still getting used to that integral symbol, even just writing it and getting used to it. Integral from a to a, f of x dx. And you do have to put that f of x dx on every single one. F of x represents the height of the rectangles. Dx represents the width of the rectangles. So all your sums, you're adding up all your rectangles, that's what that represents. Now you want to think of it as accumulating area. If you accumulate area from A to A, how much area did you accumulate? Yeah, precisely nothing, right? So that's going to be 0. If your interval is from 2 to 2, you didn't go anywhere. Do you get what I'm saying? There's nothing, right? Next one, integral from A to B, f of x dx. So that'll actually give you a result. Equals negative or opposite integral from B to A, f of x dx. And I'd like let you look at that and let that sink in for a second. It should make sense, that logical. Like if you go the other way, you get the opposite answer. So if it's backwards, you just negate it. All right. And then the third one's a little bit longer, so that's why I left the space for it over here. Integral from A to B, f of x dx, plus integral from B to C, f of x dx, equals, what do you think? Because it will follow your common sense. From A to C, f of x dx. I always think of it like a road trip. You go from point A to point B, and then if you go from point B to point C, you traveled from A to C. You just did like a rest stop partway through. But again, all 3 of those logically make sense. I think they're pretty intuitive. So for number 1, we're going to use these 3 pieces of information. Integral from 3 to 6 for x squared dx is 63. It's just true, all right? For just x, it's 13.5. Now, do you see how this one's empty? Like anything else in math, if there's not a number written in there, what do we understand it to be? 1. So if you want to put like a 1 in there, like it's a 1 dx, you can do that. It's not actually empty. There's a 1 there. All right, and that would give you 3. So we're going to answer these 2 questions using those pieces of information. So look at the first one. From 3 to 6 for x squared dx, we were told was 63. If you reverse the boundaries and go the other way, from 6 to 3 x squared dx, what do you think that's going to be? Negative 63, the opposite of 63. This one you can write as 3 separate integrals, which I recommend doing. You're allowed to take the coefficients and bring them outside of the integral. And let me make this really clear. You can only do that with coefficients. You can't take a variable and bring it outside. That's like a huge no-no. Do not ever take an x and put it outside. That's like a what are you doing kind of thing, okay? But I can take this 2 and bring it out front. So I'm going to have 2 integral 3 to 6 x squared dx. And then we're going to do the second one. It'll be minus 5 integral from 3 to 6 just x dx. We're just breaking it into 3 like separate things here. Plus 4 integral 3 to 6 just dx. And again, if you want, you can put the 1 in there. I do kind of recommend that. It helps. It reminds you it's not empty. There's a 1, like a placeholder there. But then you're just going to use the pieces of information that we have. This first part is going to be 2 times what? 63 minus what's going to come next? Well, it'll be 5 times 13.5 plus 4 times 3. And we did enough of having to work that out without a calculator on the warm-up, so I'm going to let us just leave it as that. If it's free response, you get to stop anyway. But do you see what we did? Like we just took the pieces of information and put them where they go. Also, I want to make this really clear. Oh, and we'll review. Derivative means what? Derivative means slope. Integral means area. Good. Derivative means slope. Integral means area. So what you're finding, there are areas under a graph. You're accumulating area. Now, number two is the exact same kind of thing we just did, except instead of the numbers being given to you, you have to find them yourself. Let's review some geometry. You're going to have to be able to find areas of some basic shapes. How do you do the area of a rectangle? Length times width. How about a triangle? 1/2 base times height. How about a circle? That's the circumference of a circle. Pi r squared is a circle. So if you get a half circle, it's 1/2 pi r squared. And I've also seen them do a quarter circle. That would be 1/4 pi r squared. And then a trapezoid. 1/2. 1/2 height. Base 1 plus base 2. Okay, so those are all your like basic shapes. So when we look at this one, let's go find the areas first. Our first shape is this triangle right here. That's 1/2 base times height. So what is the base of that triangle? How many units is 5? Good. And then the height is 4. So what would that work out to be for the area? Be 10. Good. Then you have a semicircle. It will be 1/2 pi r squared. A whole circle is pi r squared. We want half of it. So what's the radius of the semicircle? It's 3. Good. 3 squared is 9. So 9/2 pi. But it's actually going to be negative 9/2 pi. Why do you think it's negative? Below sea level. It's like a de-accumulation. It's like money out of the bank. And then we've got this last little triangle. 1/2 base times height. The base is 1, the height is 2. So just 1 for that. All right, and then you're just going to use those to answer the question. So again, it's the exact same thing we did in number 1, but those numbers weren't provided. We had to find them ourselves, all right? So integral from -5 to 0, what do you think? 10. From 0 to 6. Yep, -9/2 pi. Perfect. From 6 to 7, 1. Those are just the shapes we found. All right, now we're going to start putting them together though. -5 to 7 is everything. So you have to add it all up. Yeah, -9/2 pi, whatever that is. Yeah. Now this one puts an absolute value. That means you're going to treat all the areas like they are positive. So it would be 11 plus 9/2 pi. Perfect. And then you might want to watch me point to this one. It goes from 0 to -5. So look, that starts here and goes that direction from 0 to -5. So yeah, anti-10. It's like an un-10. 10 the other way. Cool. These two, you don't even have a picture. You have to draw it yourself. Do you see how I keep on removing more and more information? You have to find it yourself. So we're going to have to graph these ourselves. You'll be okay. So we want the area under this graph from -2 to 4. What would this graph look like? Because we're about ready to draw it. It's a line. It starts up 2. And your slope is 1/2. So do up 1/2 a couple of times. I realize it won't be perfect without a grid, but you know, just do your best so you can get a visual. It'll look like this. Sometimes you have to do that. Like they're not going to give you grid paper. Like sometimes you just have to draw a quick sketch so you can see the visual of what it's going to look like. So that's our line. And we want the area from -2 to be right here to 4. So this is the area that we're finding. So what shape did we end up with? It is a trapezoid and it's on its side. Do you see how this is the height of it? Okay, it's on its side. You can either turn your paper or turn your head. All right, so our trapezoid is 1/2 times, oh good, before I could even get the words out of my mouth, the height is 6 and then add the bases together. So the first one's 1, and then the second one is 4. Good. Now that I think we could work out. That's not too bad. Half of 6 is 3, and then that would be times 5, so 15. If it's not too bad, we'll do it. All right, and then we'll do this one, and then we'll do our like halfway break. Absolute value means it's going to be a V shape. The center point for the V is not a nice number. This one's going to be fun with fractions. It won't be as bad as the warm-up we did though. Do you see how it's 3x plus 4? If you were to set that equal to 0, what would you get? If you did 3x plus 4 equals 0, negative 4/3. So where you're going to hit the x-axis is negative 4/3, which is negative 1 1/3. It would be like there-ish. That's the center of the V. The V is going to go like this. Now, there are 2 other numbers it would be very beneficial to plug in. Which 2 other numbers do you think we should plug in? Why negative 3 and 0? They're your boundaries, all right? So let's plug in negative 3. If you plug in negative 3, what are you going to get? Negative 9 plus 4, negative 5, but it's actually 5. So we get negative 3, 5. So it's going to go like this. And then if you plug in 0, you're going to get 4. Good. So it's going to go like this. So the V shape is nice and even, but the parts that we're looking at are not. So like these are the areas we're going to get. You get 2 triangles. It's going to look like kitty cat ears, but they're not like exactly symmetric. If they were, you could just do one of them and then like times it by 2, but we're going to have to do them both separately. All right. So a triangle, 1/2 base times height. They're going to be fractions, but you'll be okay. I promise it's not going to be as bad as the warm-up. So look at the base for this first one. Oh my gosh, great. How'd you get that? Because that was way faster. I thought I was going to have to like pull that out of you guys. Yeah, 1 2/3. So 5/3. Good. And then what's the height for that one? 5. Good. That was the easy part. Plus, and then 1/2 base times height for the other triangle. The base for that one's 4/3. Oh, wow. Okay, cool. We didn't have any issue with that. And then the height is 4. I promise it won't be too bad, so I'm going to finish it up. 5 times 5, 25. And in the denominator, you would have 6. Good. Plus, this one's going to be really similar. 16 6. And if you add that together, whoops, it'll be 41 6. See. All right, so go ahead and flip over. What I want you to do real quick and just compare with your group members is go ahead and do A, B, C for these ones. You're going to do the derivative for each of those. And you should notice they're all the same thing, and they're all what? They're all 4x minus 3. So that's doing a derivative. What we're about to do are antiderivatives, which means you're going backwards. An antiderivative is the inverse of a derivative. But here is the thing. All of those ones we just did came out to the same answer, but were they the same problem? No. What's different about them? And what do we call that number at the end? A constant. You can have a constant added or subtracted at the end. So whenever you do these, you're going to put plus C at the end of every single one of them for that constant that might be there, plus C. It is so important that when we get to differential equations, which is the last unit we're going to do, on the AP exam, they make writing plus C worth a whole point just by itself. Okay? It is that important. So you need to make sure that you put that. Here's how it's going to look. Integral f prime of x dx equals f of x plus c. What you're looking for is a function that if you did the derivative, you would get what's there. It's kind of like Jeopardy, like you have the answer and you're looking for the question. This is how I made up the problems for everything we've done so far. I figured out what I wanted the answer to be, and then I did it backwards. You get what I'm saying? Okay. This is what we call an indefinite integral. All the ones you've done so far are what's called definite integrals. Those have boundaries. Like you would have integral from 2 to 7 or whatever, and you would find the area underneath of it and get an actual answer. Indefinite, do you see how I didn't put any boundaries on that? So you can't find the area because it's indefinite. It's like from where to where. So you just do the antiderivative and put plus c. I don't usually explain this. I usually just throw it to you guys and see how it happens. And when you kind of discover it yourself, it goes really well. Let's look at the first one. You need to come up with a function that if you did the derivative, you would get 0. So like 3 or 30 or 49 million. So just C. Any constant, if you do the derivative, you're going to get 0. So look at the next one. You need to come up with a function that if you did the derivative, your answer would be -3. Good, -3x plus c. If you did the derivative of that, you would get -3, like that's the answer. How about this one? 5x plus c. Good. You want to come up with a function where if you did the derivative, you would get 5, like 5 is your answer. Now, this is where it starts to get a little tougher because I threw a variable in there. You need to come up with a function, look at just the x, where if you did the derivative, you would get x. X is the answer. You're close. I think you said it a little jumbled though. I think you have all the right parts, but they're not in the right. Good. 1/2 x squared. So let's break down what you did there. You added 1 to the power. That's how you got the squared. And then you divide by that number. So let me write that down here. You add 1 to the power and divide. It is the power rule in reverse. Because what do you do for a power rule? You multiply, and then what do you do to the exponent? Take away, you subtract. So instead of multiply and subtract, you're adding and dividing. It's reversed. It's the inverse, okay? So 1/2 x squared plus, then what would you get for the 10? 10x, good, plus c. As a heads up, Delta Math will mark it wrong if you don't put plus c. Some people had that happen yesterday, so just, it's important. All right, what do you think about x cubed? We're good, plus c. You end up with a lot of 1/4 x to the 4th, or 1/5 x to the 5th, or 1/9 x to the 9th. Like, that's really common. All right, look at this one. I'm going to cover up the 1/3 real quick. Just ignore that. What would be your antiderivative for x to the 5th? Good, it would be 1/6 x to the 6th, but you would have to multiply that 1/6 times 1/3. Good, 1/18 x to the 6th plus c. That's really common. That just happens all the time. That's just like a thing. All right. What do you think about 3x squared, antiderivative? That would be x to the 3rd. If you do the derivative of x to the 3rd, you get 3x squared. Plus, all right, you need a function that if you did the derivative, you would get 4x. 2x squared, good, plus c. All right, now these next few, we're going to rewrite them before we do the problem, okay? So number 13, rewrite it. Integral, and how could you rewrite 1 over x to the 7th? X to the -7th dx. Negatives are hard, okay? Notice I didn't do the problem yet, I just rewrote it. Now you still want to add 1 to the power. When you add to a negative number, it makes it less negative. So this would be x to the what? -6 And so out front, you would need a -1/6. When you add to a negative number, it becomes less negative. All right, now let's try this one. Again, we're going to rewrite it first. How would you rewrite cube root of x? Good. Perfect. This is going to be fun with fractions. You add 1 to the power. So 1/3 plus 1, good, is 4/3. Now that means out front, you put the reciprocal. So out front would be 3/4. Good. Oh my gosh, this is going great. Plus C. I wrote it, I just didn't say it all. Thank you. This one is going to be negative and a fraction. How would you rewrite that one? -1/2. Good. So you're going to add 1 to the power. -1/2 plus 1. Good. That would be +1/2. So what would you have to put out front? 2. Perfect. Plus C. This one, same thing. I'm going to take that 2 in the numerator and put it out front of the integral. You're allowed to do that with a coefficient. Don't ever put an x out there, though. That's not allowed. All right, and then how would you rewrite that one? Yep, -1/4. So you're going to add 1 to the power. -1/4 plus 1 would be 3/4. Now hold on. That means out front, you would want to put 4/3, but you have to multiply it by 2. So it would be 8/3. Good. Plus C. All right, done with that. Let's move on to the trig. You need to come up with a function that if you did the derivative, you would get sine. Use brain, then speak. Negative cosine x plus C. Because the derivative of cosine is negative sine, you need the negative there to cancel it out. All right, which one of your trig functions, and hint, it's not sine or cosine, has this as its derivative? Like secant, tangent's the answer. Good. Secant of x plus C. So which one has cosecant squared as its derivative? Oh, it will be negative. I think you said it. Cotangent of x plus C. The derivative of cotangent is negative cosecant squared, so you just have to put the negative in there to cancel it out. Now you catch a break with this one. It's my absolute favorite. What's the derivative of e to the x? So the antiderivative of e to the x is e to the x. So this is 15 e to the x plus c. I love it. It's the best function, exponential. All right, 21. How would you do antiderivative for x to the 4th? 1/5. Good, x to the 5th minus e to the x plus c. You need a function that if you do the derivative, you will get 1/x. It is ln. Now, I don't say this every time because it's a mouthful, but it's actually ln of absolute value of x. I usually just say ln of x, but the reason why is you can't ln a negative number. So when you go backwards, you just have to ensure that that value is positive. So it's ln of absolute value of x. Yes. I'm thinking of a way I could give you a different answer, but all right, for this one, the 3 throws everybody off. Remember, you're allowed to take that coefficient and bring it out front. When I write it that way, all of a sudden everyone's like, oh, I see it. So just write it that way. If you bring out the 1/3, then you can see it better. So your answer would be 1/3 ln of x plus c. I get why that looks funny to everybody because the 3 ends up in the denominator, but just remember you can take that and write it out front.